Good morning, ladies and gents. This is our second lesson this week, and now what we're going to do, we're going to look at some of these elements we spoke about from the groups from yesterday. So we spoke about the alkaline metals in group 1, alkali earth metals in group 2, and the halogen in group 7. Now we're going to start with magnesium. This is called the magnesium strip. Okay, it's quite bendy. Magnesium is a metal. It's in the second group. That means it's alkali earth. And if you remember, we said alkali earth are reactive metals, but not as reactive as alkali metals. Now, what does it mean reactive? Okay, they will react in a chemical reaction quite easily, but not as easily as the alkali metals. And now you can see that, the reaction I'm going to show you is when it reacts with oxygen. But you know that there's plenty of oxygen around in the air, and right now it's not doing anything. So it's not that reactive. To make it react with oxygen, we're going to need to supply some heat. Okay, so now if you were in this classroom, in the class, I would tell you when I'm burning this magnesium not to look directly at it, because it gives off a lot of light, and it can actually cause a damage to your eye. Through the camera, I don't think it's as bad, and I try it. But again, if I were you, I wouldn't look directly at the flame. So let's have a look at that. Don't look at the flame. Okay, and that should show you that it's not the gas that is doing it. You can see how bright it is. This bright light and the heat that it gives off as well, I can tell you, I feel, is a sign of a chemical reaction. There's a chemical reaction happening between the magnesium strip. You see here, in this bit, it actually didn't do anything. But here it reacted with oxygen and created this powder. You can actually touch it. I'll just show you a little bit closer. You can see this powder here. Right? Can crumble it. This is not magnesium anymore. Magnesium reacted with oxygen to form magnesium oxide. Okay, so we're going to pause here. Okay, it's me again. So next we're moving to the alkali. Let me just talk to you like this. Okay, we're going to move on to the alkali metals. And I've got two kind of metals here. First one, they look very funny. Okay, this one is called sodium. Okay, it looks a bit like tofu. Okay. And the second one is potassium. Now you can see, especially with potassium, over here you can see it's a little bit shiny. I hope you guys can see it. Now these metals are from the alkali metals, and they're very, very reactive. Okay, that means that we don't normally find them in their pure state. They always want to react with other elements. Next year you're going to understand why. And that is why we keep them in this brine. Okay, this is where the potassium, it's in some kind of oil substance to basically make sure it doesn't react with the air, because especially with the humidity in the air. Okay, it's very, very reactive, and we're going to see their reaction with water. Much more interesting than magnesium, I think. Magnesium is quite cool as well. Right, so the first thing I need to do is slice them. So I'm going to start with sodium, and you can see that even though metals are usually hard, I can actually slice it. I'm slicing it, cutting it with this little blade here. And I can just tell you that it's sliced kind of like a hard butter on a cold day. So this is my sodium, and you can really see here that it's shiny. I hope you can see it kind of shining on the air. Okay, now before I dip it into the water, I need to put the screen to protect, not to protect you, you guys are fine, but I just need to protect my computer. Okay, right. So here it goes. Okay, I'm going to just move these guys away. Put my goggles on. Here it goes. I don't know if you can see it sizzling. You can see a little bit of smoke. Okay. Probably not that easy to see it. Maybe I'm going to bring it a bit closer like this. You can definitely see it, hear it sizzle. Okay, it's moving around, giving a lot of fume. Okay, and we let it just relax here. Ooh, I can smell these fumes. Okay, so that was sodium. Okay, now what we're going to do, we're going to cut some of potassium. Okay, so potassium, I'll do a little smaller bit, so you'll see in a minute why. Okay, so again, I think before I do that, I'm going to just see if I can bring it a little bit closer. I hope you guys are going to see it. If you don't see it, I will just do it one more time when I'm holding the camera close, okay? Or if you missed that one. Woo! Do you see it? Definitely see that flame. So it sizzles again, but now it gives much more gas coming up. And also you saw that red flame. I'm sure you did. I'm going to put one more, a little bit bigger this time, and I'm going to run away back. Fire in the hole! Woo! Fantastic. Isn't that cool? Potassium. Very reactive metal. Sparks flying in the air. You can see it. Thank goodness I've got the screen, otherwise my laptop wouldn't survive. Okay, we're going to pause here. Move to the next reaction. Okay, guys, this is the last chemical reaction that we're going to see today. And this one involves iodine. Okay? So you've got these little ballies. Oops, I made a bit of a mess here. Never mind, clean it later. Okay? We've got a bit of iodine. Now, I think I've shown you iodine already earlier this year. And this experiment we're going to do now is a little bit similar. It has kind of the same result as the experiment I showed you, but it is actually different. So iodine is a solid. Okay? It belongs to the group 7. It's a halogen. And the one cool thing about iodine, which I think I already showed you, that it sublimes. Remember what sublimes mean? Sublimes means that it goes from solid straight to gas. If I heat that solid, and I think that's what I showed you, I just heated it up, it went to that beautiful purple, call it purple haze, okay, which is gas form, okay? But I'm not going to heat it up today. The opposite. I'm actually going to give it some water, okay? But it's not that the water causes it to sublime. I'm just going to show you that, okay? What I'm going to do, I'm going to react it, okay, with magnesium, okay? Magnesium, a minute ago I showed you that in powder form, in a strip, like a metal strip, but it actually can also exist in a powder form, okay? So I'm going to mix these two together, magnesium and iodine, okay? Let's put a little bit more iodine, eh? Put a little bit more iodine, okay? Crush it. I need to crush it into a powder. And so far, nothing really happens, isn't it? Okay, it's a little bit boring. So magnesium is alkali earth. It's not as reactive, okay? And halogens are quite reactive, okay? But as I said, right now, nothing much is happening. So I'm mixing it a little bit. Nothing much, okay? Next year, we're going to learn a little bit more about chemical reaction, but I can already tell you one little secret. Sometimes you need to stimulate the chemical reaction. You need to kind of convince the element to go on, react, okay? And sometimes we can use heat, like we did just now with the magnesium. We heated up the magnesium and it reacted with oxygen. And sometimes you can add a catalyst. And this is what we're going to do now, a catalyst. Catalyst is something that speeds up the reaction. So we'll do that, okay, by adding a little bit of water, just simple water. Now, it doesn't always work. Sometimes I put too much water. So if it doesn't work, don't worry, I'll show it to you again. And it does take a little while. Opa, and then you see this beautiful purple smoke. Actually, that's really cool. Now, I've done it outside, and you can see I'm stepping out because, woo! Did you see that? It just broke. That was amazing. That never happened before. How cool is that? Okay, let me try and explain what happened. What you saw is the iodine subliming. It turns into gas. But that was just a consequence of a chemical reaction. I didn't heat this the iodine. What happened? The iodine reacted with the magnesium to form a new compound, okay, as we're going to learn next week, called magnesium iodide. Okay, they reacted together, and by reacting together, they released a lot of heat, okay? And that heat, one thing it did, it broke the glass, but the other thing it did, it also heated up the rest of the iodine, which then evaporated straight away, or sublimed, not evaporated, turned from solid straight to gas. So how cool is that? Right, have a lovely, lovely rest of the week, and I'll see you in the third lesson.